Hi guys, thank you so much for joining me in my session about Maven Taming the Beast. I'm very glad to see such a big room with so many people. It's really overwhelming for me, so a lot of responsibility. Anyway, allow me to talk a little bit about myself. My name is Roberto Cortez. I work for this company called Tomitribe, which develops an awesome application service called Taming. So here's my Twitter handle, my email, and my blog, so you can reach me on any of those. If you want to ask me any questions or if you want just to contact me for something else. So running exactly into our presentation, let me ask you something beforehand. Do you guys hate Maven? Oh, a couple ones. So please shout me, what are the reasons that you hate Maven?
Too slow.
Sorry?
Too slow.
Too slow. More.
XML.
XML, more. Complexity, more.
Very rigid.
Very rigid, more. Okay, so probably it's XML, complex, verbose, hard to extend, step learning curve, slow, unreliable, and sorry.
Hard to get rid of.
And that's it. So, yeah. So as you can see, you told me like a couple of some of the reasons that you put here. Those are the reasons that I heard the most when I'm working with the teams that work with Maven, and that was one of the reasons I came up with this session because I hear all the complaints all the time, and yeah, I might don't like Maven that much as well, but I try to make the most out of it and try to make it work for me instead of against me. So the session is going to explore some of the things that we can do to help Maven work for us instead of having to be a slave of Maven. So we have so many people in the room, and I think that's one of the reasons why, if we can see here, oops, okay. So this is a popularity report from Repo Labs. So they make a build tool reports where you can see that on 2010, Maven was like 53% popularity and actually been increasing. Gradle been increasing as well, and then Ant been decreasing a lot. So this is like a paradox for me. It's like a lot of people hate Maven, but the popularity of Maven has been increasing over the years. So let's try to understand why. So Maven is a very, very old tool. It's been around for more than 10 years. And all developers pretty much run into problems. I heard all the same problems every time. So I'm going to try to talk some of the most common problems that we have in Maven and how to solve them, or at least have some tools that can allow us to debug those issues so we can more easily make Maven do what we want it to do. So what are the most common pitfalls? Let's see some of those. Who here knows what a transitive dependency means? Yeah, just probably 25% of the room. So one of the reasons why Maven is very heavy and why people don't understand is when you add a dependency into Maven, it will not just bring that dependency into your project, but also bring the dependencies that are dependent on that project, and so on and so on and so on, like in a recursive way. So as an example, you have your POM file over there. Then you add a dependency. That dependency is going to bring you 3 more or even more. Those dependencies are going to bring even more. And it really depends on how you have your graph. So sometimes you put a dependency in your project, and that dependency is going to fill your project with a huge amount of jars. And then you end up to that question that is, why is the jar in my build? Why is it there? I didn't even add it. So this is one of the reasons why you get that jar in the build. And sometimes when you have this all transitive dependency adding all these jars into your build, it will make your project fail because then leaves are going to clash with each other, maybe versioning, maybe other builds that you're using. So how we can handle all of this? So one particular good plugin that you can use on the command line is use Maven Dependency Analyze. So Maven Dependency Analyze will tell you the dependencies that you're using as on your project, and the ones that are being included but are not being used on your code. So it's a very, very useful tool to use. Something that you can do is when you're including dependencies that you don't want, because those are being included by the transitive ones, you can exclude them directly on the XML. So just use an exclude element. And some trial and error, of course, is involved. So usually I go around using Dependency Analyze and excluding dependencies until you're happy with your class path and wherever you have there. Hey, I didn't say it was going to be easy, right? Another thing that teams usually tell me is that they do some change and they cannot see the change that they just did on the code. This is because dependencies, when you're building a project, they are building your local repository. So who's here familiar with local repositories and remote Maven repositories? Yeah, most of us. Awesome. So sometimes this means that when you cannot see the change, maybe it's because you haven't built that dependency on your local repo, or maybe the version is not right, but there's some other things that can happen. So let's see in this diagram. So you have like this project, POM, and then you have a dependency A, dependency B, and imagine that you do some changes on dependency B, on your own source code on dependency B. So you have to remember, you have to install that in a local repo. Now, sometimes the problem is when some other guy on your team is also making code changes on dependency B, and then you have a remote repo where you have a Nexus repository, an artifact repository, and you're pulling snapshot versions from there. So then every help goes loose there, meaning that you have to check out if your local repo is synchronized with your remote repo. So it's a pain. Usually the most easy way to fix this is running the MVN install. That's why everyone tells you when everything else fails, you do MVN clean install to fix that. But this is one of the common issues why you can actually see the changes that are going on. Because someone might make changes and put them on remote repo. When Maven gets them, it will override the changes on your local one, and then you have to redo the changes again. So another thing I want to tell you about is about dependency mediation. So who here heard about dependency mediation? Yeah, just one person apparently. So dependency mediation happens when you have the same library, but there's different versions included on your class path. And you cannot do that, right? So Maven needs to have a way to actually know which version it's going to use. So they use something called dependency mediation, which is the shortest dependency on the graph is going to be used at first. So let's imagine that on this particular diagram, we have dependency A and B, and then we have a C1 and a DV1 and a DV2. So let's make it simple. Let's imagine it's like a commons logging dependency. Who here doesn't have problems with commons logging dependencies? Yeah, you can raise your hand. We are all familiar here. So in this particular case, what Maven is going to do is going to instead, imagine that you want to use DV2, but since the nearest shorter dependency is DV1, so it's a different version, so commons logging, for instance, version 1, and commons logging version 2, instead of using the latest one, which should be version 2, it will actually use version 1, because it's the closest on the graph. So in this case, who wins is version 1. So to fix these kind of problems, you have either exclude version 1 from dependency B, and then of course you only have one on the class path, or you can trick Maven and you can actually have direct dependency to version 2 on your POM file over there, and then it will be the first one on the tree, so it will be the first one to be included, and then DV1 will be discarded. Now, some tools that you can use to actually see these is the MVN dependency tree. So MVN dependency tree is a command that you can use that will show you all dependency and tree style format. So you can actually see which are the graphs that are being using and how they are being included in your project. Also, the snapshot versions that coming from your repo can override the changes, so be careful with that. Another common issue that teams tell me is the jar is not being included in the project. So one of the reasons that this might happen is because of scopes. So who here is familiar with scopes? Yeah, most of us. Anyway, as you know, there are like scopes like compile, runtime, test, and they control how jars are going to be handled on the class path. So sometimes you think that the scope is compile, but it's runtime, or depending on the dependency tree that you have, the scope may be overridden by someone else. So you have to look into all of those to see if you have the right scope to be able to see if the jar is actually included on your class path. So again, use dependency list, which shows all dependencies, and it will show you which exact scope is be using on the project that you're running. Also, whoever, tell me if anyone is here that never got this error. You never got it? Really? Wow, that's probably the first one. Anyway, so can't find the artifact is like a pain for me. It's kind of like a null pointer exception in Java for me. So there are like multiple reasons for this to happen. And a few of those are dependencies might not be included correctly, so like you mismatch the version or you misfactor the artifact or the version, so you always have to be careful on that. So for instance, for IntelliJ users, IntelliJ can actually validate the ones that the artifact and the version and the IDs directly with your local repo. So if it's not there, it will show you on red. So meaning there's something wrong. The remote repo may not contain the repository, so sometimes you have to go to remote repo and use the browser explorer to see if the jar is actually there. Sometimes not using the recent version, and sometimes we even run into some really strange issues. Sometimes I had this problem once where the remote repo was actually asking me for authentication, and it was downloading the jar as an HTML. So the jar was being included on the project, but it was just an HTML page. So when I tried to build the project, it will fail. But the jar was there. So I have to like look, see what's happening, look into the logs. So if you have these kind of issues, you know at least what things that you can check. So check if the jar is corrupted in this way. Sometimes if you're in your company, you have a local enterprise repository, the artifacts might be cached there, and they might not be going into the remote repos to get the latest versions. So you have, on that particular occasion, you have to go to the Nexus repository or Artifactory and see what artifacts are there on your enterprise versions of the repositories. Or the dependencies might be overridden by some other things on your project. So there are some tools that you can use to actually see to fix this, or at least help you fix this. That's what I call like the weapons of choice. So MVN Help Effective POM is one of my favorite tools, because remember when you have a parent project which has all the settings that you want? Who here uses that? Yeah, a couple of you. So effective POM, it will actually build like a huge POM file where we'll bring everything that's coming from the POM parents, and we'll put everything on a single file, so you can see exactly what's being built, exactly what's being included, exactly all the versions that are being included, even like when you're using dependencies versions, you can see which ones are there, and it will be easy to debug. Also, if you use Maven repo equals, you can like point your local repo to a new path, and Maven will download everything, so you can see, and you can start with a new repo and see if everything's okay. And of course, -O to do it offline if everything else fails. Bonus, speed up your build. So, who here knows that Maven can build in parallel? Yeah, just a couple. So, Maven allows you to build stuff in parallel, and you can also only build the things that you want. So how we can do that? So if you use Maven, can I have like 30 more seconds? Okay, thank you. I'm almost done. So if you use Maven -t1c, it will basically create one thread for each core that you have. So it will build the project on each core that you have on your machine. So I sometimes have projects that takes like half an hour to build, that takes like only 8 minutes with this setting. And with -pl, you can actually pick which models you want to build on your project. And -imd is like also make and -amds also make dependence. So it will build all the dependence project of that. And the -o, of course. Do you guys think that's tames already? Well, sometimes it might bite you in the ass, but at least I hope that this session helped you to figure out some of the Maven issues, and maybe you can use these tools to help you on your build. So just one last thing, never trust your IDE. If it works on the command line, something's wrong with your IDE. Thank you so much, guys. Sorry? Okay, thank you.